Welcome everyone. I'm excited to kick off today's session with our presentation titled AI Terminologies, a Practical Guide. On this first slide, you'll see the title and subtitle, which set the stage for what's to come. In this presentation, we'll explore key AI terms, making complex concepts easier to understand and apply. We'll cover the fundamentals, practical insights, and real-world applications, all designed to help you get comfortable with AI terminology. Let's get started and dive into the fascinating world of AI. Today, I want to highlight how key concepts are explained through real-world use cases, making these ideas more tangible and easier to understand. We'll explore some common AI terminology that you might have come across and see how it applies in practical scenarios. This approach helps ground complex ideas in everyday examples, which is essential for grasping the full potential of AI. Think of this as a practical guide, something that bridges theory and application, so you can better understand how these concepts function in real life. As we go through, I'll emphasize the most important points, connecting them back to the overall theme of how AI is transforming various industries and our daily experiences. By the end of this section, you'll have a clearer picture of not just what these terms mean, but how they are used in the world around us, making the technology more approachable and relevant. Why AI vocabulary matters is a question I often get asked. Well, understanding AI terminology is more than just knowing fancy words. It's about developing a practical skill that helps us navigate and communicate effectively in the AI world. When we grasp these terms, we can better understand how AI systems work and how they impact our lives. Remember, understanding AI is not just about technical expertise. It's a crucial skill for everyone involved in today's digital landscape. So, as we move through this presentation, keep in mind that mastering this vocabulary will empower you to make smarter decisions and have more meaningful conversations about AI. Now, moving on to slide 4, we're going to explore AI risks and ethics. As AI becomes more integrated into our daily lives, it's crucial to consider the potential risks involved, such as biases, privacy concerns, and unintended consequences. Ethics play a vital role here, guiding us to develop and deploy AI responsibly, ensuring it benefits society without causing harm. This is a key part of the overall AI landscape, because understanding these risks helps us create safer, fairer systems. So, as we continue, keep in mind that ethical considerations are just as important as technical advancements when it comes to the future of AI. Let's dive into Section 1, which focuses on AI terminologies and the foundations of AI. Understanding these key concepts is essential because they form the backbone of everything we do in this field. When we talk about AI foundations, we're really referring to the basic building blocks that enable machines to simulate human intelligence. This includes things like algorithms, data processing, and learning models. By grasping these fundamentals, you'll better appreciate how AI solutions are developed and how they evolve over time. Remember, these core ideas are not just technical jargon. They're the gears that drive innovation and practical applications in AI today. So, as we move forward, keep these foundational concepts in mind. They're crucial to understanding the bigger picture of AI's role in our world. Let's take a closer look at some computer systems that actually mimic human capabilities, such as decision-making, problem-solving, and language understanding. For example, think about Google Maps. It uses narrow AI, which is designed for a very specific task, re-optimizing millions of routes in real time. This kind of AI is trained for one particular purpose, allowing it to perform that task efficiently and accurately. Throughout this presentation, we see how artificial intelligence is becoming more integrated into our daily lives, helping us solve complex problems quickly and effectively. It's a core concept that highlights the power of AI to enhance and automate tasks that once required human intelligence. Deep learning is a fascinating area because it's modeled after the brain's structure, which allows it to handle unstructured data effectively. This means it can process images, audio, and text in ways that mimic human perception. It's really driving advancements in computer vision, speech recognition, and language understanding, making machines better at interpreting complex data. On the other hand, machine learning is about systems that learn from historical data without explicit programming for every task. For example, spam filters, fraud detection, and recommendation engines all use machine learning to improve their accuracy over time. Together, machine learning and deep learning form a powerful duo, deep learning being a subset of machine learning, focused on neural networks that resemble the human brain. Both are essential to the AI landscape and are pushing the boundaries of what machines can do. This connection highlights how AI is becoming more intuitive and capable, which is a core theme of our overall discussion. Now let's take a closer look at how AI learns. On this slide, titled How AI Learns, we're focusing on the fundamental processes behind machine learning. Essentially, AI systems learn by analyzing large amounts of data, recognizing patterns, and making predictions or decisions based on that information. It's similar to how we learn from experience, by observing what works and what doesn't. The key idea here is that AI doesn't know things in the way humans do. Instead, it improves its performance through training, adjusting its algorithms as it processes more data. This iterative process is what allows AI to become more accurate and efficient over time. Understanding this concept helps us appreciate the practical applications we see today, from recommendation systems to autonomous vehicles. It's the foundation that enables AI to adapt and solve complex problems in real-world scenarios. So, in essence, AI learns through continuous exposure to data, refining its understanding and capabilities with each iteration. When the model applies its knowledge in real time, think of it as a chatbot responding to your question instantly. This process is called inference, and it's where the trained system takes new inputs and makes predictions based on what it has learned. The model itself is like the brain of the system. It's the set of rules and patterns it follows to identify relationships and improve over time. Now, all of this relies heavily on the training data, which is the labeled dataset used to teach the model. The quality of this data really matters because, if you feed it garbage, you'll get garbage results. Finally, the algorithm is the specific method or procedure the AI uses to analyze the data, find patterns, and learn. So, in essence, training, models, and data all work together to enable AI to perform tasks in real time effectively. Now, let's take a closer look at the main types of machine learning. First up is reinforcement learning. This approach learns through trial and reward, meaning it tries actions and learns from the outcomes. It's often used in game-playing AI and autonomous robots, where the system improves by constantly experimenting and receiving feedback. Next is unsupervised learning, which is all about finding hidden patterns without any labeled data. It's very useful for tasks like customer segmentation, where understanding groups within data is key, or anomaly detection, which helps identify unusual patterns that might indicate issues or fraud. Finally, we have supervised learning. This method trains models on labeled data, so the system learns to recognize patterns based on known outcomes. It's widely used in fraud detection and medical diagnosis, where identifying specific conditions or behaviors is critical. These three approaches, reinforcement, unsupervised, and supervised learning, each address different kinds of problems. Selecting the right one depends on the specific challenge you're tackling, and understanding these differences is fundamental to applying machine learning effectively across various domains. Now, let's talk about generating content with AI. This is a really exciting area because AI tools can help us create a variety of content quickly and efficiently. Whether it's writing articles, designing visuals, or even crafting social media posts, AI can assist us in producing high-quality material. The key point here is that AI doesn't replace human creativity, but rather enhances it by offering new possibilities and saving us time. It's important to highlight that understanding how to leverage AI effectively is crucial to staying competitive in today's digital landscape. Connecting this to the overall theme, Integrating AI into our content creation processes can significantly boost productivity and innovation. Let's take a closer look at what generative AI and large language models, or LLMs, can do. One of the key strengths is their ability to generate marketing copy at scale. That means they can help create ad headlines, emails, and product descriptions quickly and efficiently, saving time while maintaining quality. They're also powerful when it comes to drafting legal documents. Whether it's contracts, clauses, or summaries, they can produce clear, plain language explanations that make legalese more understandable. On the technical side, these models can write and debug code. They generate boilerplate code, identify bugs, and even explain complex logic, which can boost productivity for developers. Another impressive capability is summarizing research papers. Instead of spending hours reading dense documents, these models can extract key insights in seconds, making research much more accessible. But it goes further. These models analyze not just text, but images, audio, and even geolocation data simultaneously. This multimodal understanding allows for a richer context, which is crucial for more sophisticated applications. They're trained on massive datasets, like GPT-4, Google Gemini, and Claude, enabling them to produce responses that sound remarkably human. They're not just regurgitating information, they're creating new content, be it text, images, music, or code, by learning patterns from existing data. Overall, generative AI and LLMs are transforming how we create and understand content, making processes faster, more efficient, and more innovative. They're powerful tools that open up new possibilities across industries. When AI confidently generates incorrect information, it can be quite problematic, especially in fields like legal, medical, and financial sectors, where accuracy is absolutely critical. In these high-stakes contexts, it's essential to always verify AI outputs rather than taking them at face value. Even if the AI seems confident, there's still a risk of it producing hallucinations. Those are the false or misleading outputs that the AI might generate without any real basis. This brings us to the importance of the input we give to AI to guide its output. The quality of our prompts plays a huge role here. Clear and specific prompts tend to produce much better results because they help the AI understand exactly what we're asking for. That's why prompt engineering has become a core skill in working with AI today. Crafting the right prompts is almost an art. So two key terms every AI user must know are prompt and hallucination. Understanding these concepts helps us better manage AI's capabilities and limitations, ensuring we use AI responsibly and effectively within the overall theme of our presentation, recognizing how to leverage AI's power while mitigating its risks. Let's take a closer look at AI in action. Here, we're seeing how artificial intelligence is not just a theoretical concept, but something actively transforming various industries. AI can automate complex tasks, analyze large datasets quickly, and even make real-time decisions. This slide highlights some of the most impactful applications, from personalized recommendations in e-commerce to predictive analytics in healthcare. What's important to understand is that AI's capabilities are constantly evolving, and it's becoming an integral part of everyday operations. Connecting this to our overall theme, AI's practical deployment demonstrates its potential to drive efficiency, innovation, and competitive advantage across sectors. So, in practice, we're seeing AI agents taking on real-world tasks. For example, they can book meetings, send follow-up emails, and even update a CRM system, all without any human intervention. This demonstrates how advanced these systems have become. This brings us to the concept of agentic AI, which refers to systems that pursue complex, multi-step goals with minimal oversight. They're rapidly expanding in enterprise environments, helping companies streamline operations and reduce manual work. Now, AI agents are autonomous entities designed to perform specific tasks for a user or a system. Think of chatbots, virtual assistants, or even autonomous drones. They act on your behalf, making decisions and executing actions without constant human input. Bringing it all together, AI agents and agentic AI are essentially autonomous systems that act on your behalf. They're not just simple tools anymore. They're sophisticated entities capable of handling multifaceted tasks, which really exemplifies the shift toward more intelligent automation in our work and daily lives. Now, let's talk about transfer learning. Essentially, it involves taking a pre-trained model that's already learned a lot from a large dataset and fine-tuning it for a new, specific task. This approach saves us both time and computational resources. For example, we might start with a language model trained on general text, and then adapt it to understand and process legal documents more accurately. This way, we don't need to train a new model from scratch, which can be very resource-intensive. Moving on to workflow automation. This refers to AI-driven tools that help streamline our business processes. By automating routine tasks, we can reduce human error and boost overall team productivity. Think of tasks like data entry, scheduling, or customer service. AI can handle these efficiently, freeing up our team to focus on more strategic work. Then, there's AI automation itself. This is about integrating AI directly into our workflows to perform tasks automatically, without manual input. For instance, AI can flag potential fraud in transactions or automatically approve loan applications based on predefined criteria. The key idea here is that AI takes over repetitive, rule-based tasks, making our processes faster, more accurate, and more consistent. All of these concepts, transfer learning, workflow automation, and AI automation, are central to the broader theme of AI-driven process automation. They show how AI is transforming how we work, making our operations smarter, more efficient, and more reliable. Let's take a look at how AI is making an impact in the real world. This slide highlights some key points about the practical applications of AI in everyday life. First, AI is transforming industries like healthcare, where it's helping diagnose diseases faster and more accurately. In finance, AI algorithms are improving fraud detection and personalizing investment strategies. We also see AI in retail, powering personalized recommendations that enhance the customer experience. And in transportation, autonomous vehicles are becoming a reality, changing how we think about commuting. All these examples show how AI isn't just a future concept, it's actively shaping our present. This ties into our overall theme of understanding AI's capabilities and how it can be harnessed responsibly. By seeing AI in action, we grasp its potential to solve real-world problems and improve our daily lives. Now, let's look at some of the real-world applications of AI across various industries. Virtual agents, for example, are increasingly handling support and sales queries, and they do this by simulating human conversation, making interactions more seamless for customers. They can also personalize product recommendations for each shopper, enhancing the shopping experience and boosting sales. In logistics, companies like UPS use AI-optimized routing to significantly reduce fuel consumption, saving millions of gallons each year and contributing to sustainability efforts. In healthcare, AI is helping detect anomalies in radiology images with high accuracy, which can lead to earlier diagnoses and better patient outcomes. AI also plays a vital role in public health by predicting disease outbreaks using search trend data and population analysis, helping authorities respond more effectively. Additionally, some financial institutions automate loan approvals at scale, speeding up decisions and improving efficiency. All these examples highlight how AI is transforming industries by making processes smarter, faster, and more efficient, which ties back to our overall theme of how AI is shaping the future of work and business. Let's take a moment to talk about AI risks and ethics. As we develop and deploy AI technologies, it's crucial to consider the potential risks involved. These include issues like bias, privacy concerns, and unintended consequences that could arise from AI decision-making. Ethics come into play here, guiding us to build systems that are fair, transparent, and responsible. It's not just about what AI can do, but also about what it should do. By understanding these risks and adhering to ethical principles, we can ensure that AI benefits society while minimizing harm. This is a vital part of the overall AI journey we're exploring today. Let's talk about AI safety, which is a rapidly growing field focused on making sure AI systems behave reliably and stay aligned with human values and intentions. One important issue is hallucination. This is when AI produces confident but incorrect outputs, which can be a serious trust risk, especially in high-stakes areas like medicine, law, and finance. We need to understand these risks because AI systems can fail in ways that are often hard to detect. Another key concept is XAI, or explainable AI. These are systems designed to clarify how decisions are made, which helps improve accountability and builds user trust. When users understand the reasoning behind AI decisions, they're more likely to trust and rely on these systems. We also have AI bias, which happens when a model reflects unfair patterns from the training data. This can lead to discrimination in hearing, lending, or justice, essentially, biases that can cause real harm. All of these points, bias, explainability, and trust, are interconnected. Understanding these risks and the ethical considerations involved is the first step toward using AI responsibly. It's about making sure AI systems serve everyone fairly and reliably, and that we're aware of potential pitfalls as we integrate AI more deeply into our lives. Now, let's take a moment to look at some of the key concepts around agents and automation. When we talk about AI agents, agentic AI, and AI automation, we're exploring how AI can act independently or semi-independently to perform tasks, streamline processes, and enhance decision-making. These technologies are the backbone of many intelligent systems we see today, from virtual assistants to autonomous vehicles. Moving on to risks and ethics, this is a crucial area. AI bias is a significant concern because algorithms can inadvertently reinforce existing prejudices if not carefully managed. Explainability, or XAI, is about making AI decisions transparent and understandable so that users can trust and verify how outcomes are derived. These terms, agents, automation, bias, explainability, are fundamental. They open the door to a deeper understanding of how AI functions and where it's heading in the future. Now, diving into the foundations, we cover core concepts like AI itself, narrow AI, which is specialized for specific tasks, and the broader goal of artificial general intelligence, or AGI, which aims to match human intelligence across a wide range of activities. Machine learning and deep learning are the techniques that enable AI to learn from data, improving over time. Understanding how AI learns is essential. It starts with training data, which feeds the model, and then the model processes this data to make inferences. Transfer learning allows models to apply knowledge from one task to another, speeding up learning and improving efficiency. There are different learning types as well. Supervised learning uses labeled data, unsupervised learning finds patterns in unlabeled data, and reinforcement learning involves learning through trial and error with rewards. Then we come to generative AI, which can create new content. Terms like generative AI, large language models or LLMs, multimodal AI that handles different data types, and prompts that guide AI output are all part of this exciting space. However, we also need to be aware of hallucinations, where AI might generate plausible but false information. To wrap up, these key terms form the foundation of understanding AI's current capabilities and future directions. Grasping them helps us navigate the opportunities and challenges that AI presents in our evolving digital landscape. Now that you have your vocabulary, you're ready to start applying what you've learned. The first step is to put your vocabulary to work, which means actively using these terms in your own AI-related tasks and projects. Once you're comfortable with that, it's important to share this knowledge with your team. Building shared AI fluency helps everyone stay on the same page and accelerates your collective progress. You can do this simply by passing along this guide to your colleagues. Next, I recommend running a prompt experiment. Try different inputs, See how the AI responds and compare the outputs. Pay attention to what changes make a difference. That's how you learn to craft better prompts. Finally, explore an AI tool within your current workflow. Use it in a real scenario and observe how it behaves. That hands-on experience is invaluable for understanding its capabilities and limitations. These steps will help you move from knowledge to practical application, making AI a powerful part of your work. Thank you. AI literacy starts with the right vocabulary. As we've seen throughout this presentation, understanding key AI terminologies is essential for navigating this rapidly evolving field. This slide, titled AI Terminologies, a Practical Guide, is meant to serve as a quick reference to help you grasp the most important concepts. When we talk about AI, terms like machine learning, neural networks, and data sets come up frequently. Knowing what these mean and how they relate to each other really empowers you to engage more confidently in conversations and decision-making involving AI. Remember, building your AI vocabulary isn't just about memorizing definitions. It's about understanding how these terms fit into the bigger picture of AI development and application. So, I encourage you to keep exploring these terms and stay curious. This foundational knowledge is key to becoming truly AI literate and ready for the future. Thank you for your attention and engagement throughout this journey.